Hello, geometry students. So we're going to go back to 8.1. We went to 8.2 and 8.3. We're going to backtrack to 8.1, geometric mean. And I kind of gave you an introduction to what geometric mean is in that last packet. So now we're going to relate it to right triangles. All right, using geometric mean to find missing sides. So that's kind of neat. You're going to need your packets. And there's this first theorem, theorem 8.1. And this shows us that if an altitude is drawn from the right angle to the hypotenuse, then the two triangles formed are similar to, excuse me, I was yawning, to the original triangle and to each other. So when we do that, when we have an altitude here, we're going to get three similar triangles. So we have A, C, B, or ABC, okay, is going to be similar. Here, I'll highlight that. ABC, ABC is going to be similar to these two. And remember, similar. What does similar mean? Do you guys remember? Right, similar means proportional. Okay. And in that packet yesterday, we were forming proportions. We were setting proportions equal to each other and cross-multiplying to solve. So that's going to come full swing here in this section. And then we have ACD, okay, ACD and ACD. And then we're going to have CBD, this one right here. So all of these are proportional to one another, these three. So just by making that altitude in this big triangle, we get three similar triangles, which is kind of neat. Okay, so here's the next slide. You guys don't have to write this down unless you want to. I'm going to show you how these triangles are proportional, because this will help us with the next theorems. So what I'm going to do is I'm going to set it up to three proportions, and three in each proportion, three ratios. So I'm going to set up the hypotenuse to the short side. And so, for example, here, I'm going to go in order. And what I did is I separated each of these triangles out because it's kind of hard to see them all as one. So the hypotenuse of the big triangle to the short leg is B. And here, I'm going to skip down here. Let's see if I'm going to skip down. I'll leave it. I'll just leave it right here. So C over B. And then here we have the hypotenuse. It's going to be A over the short leg, which is going to be H. And then we have this one here, which is going to be the hypotenuse, which is B over X. So, ooh, and look at this. We have B and B. That looks familiar, doesn't it? We did that in the geometric mean where it was X and X, so it looks the same. And here's the hypotenuse. So here we had, of the first one, we had C, and over the long leg, which is A, that's the long one. And for this one, we had A over the long leg, which is Y. And then we have the hypotenuse, which is B, over the long leg, which is H. Ooh, interesting. We have A and A here. Very similar to what we did yesterday, or what we did in class with the packet when we had X and X across from each other. We did some cross multiplication. Coincidence? Maybe. Okay, so now we're going to do the long leg to the short. So the long leg of this first one is going to be A over B. And then the long leg of this triangle is going to be Y over H. And then for this one, the long leg is going to be H over X. Interesting. We have another H and H here. Very interesting. That's going to connect with our geometric mean. So I just want to show you how these are proportional, how to set them up. Again, you don't have to write this down if you don't want to. Now these theorems you do have to write down, so why don't you go ahead and pause the video and write these down. All right, let's see what these are talking about. So this one is saying that when you have an altitude to the hypotenuse, you can say that the altitude h is equal to the square root of x times y. And that's because we set this up in the last slide, x over h equals h over y. And so remember in that packet, we can use the geometric mean, we can cross multiply to find that. So it actually ends up being h squared equals xy, and we can square root both sides. So h equals the square root of x times y. Here, in this case, we have some proportions. C over b equals b over x. And so when we do that, to find this little side here, or to find what b is, the short side, the short leg, you can say that b squared is equal to c times x, square root both sides. So b equals the square root of cx. Same thing over here. If you want to find the long leg, it's a squared, because a times a, equals the square root, or excuse me, equals cy. Then we're going to square root both sides, and a equals the square root of cy. Or yes, cy. Sorry about that. So this is where geometric mean comes into play. Okay, setting up these proportions and then square rooting, or using cross multiplication, then square rooting to find them. All right. So we're going to use it to find x, y, and z. So if we notice, x is the altitude. So we got to go back and look at our theorem. And so x is the altitude. So what we can do is take x equals, and it's going to be these two sides right here. And it's going to be the square root of 20 times 5. Now if you like setting up your ratios, your proportion, go ahead and do so. If you like setting up the fractions, I just kind of like knowing that it's the square root of those two things times by each other. So x equals the square root of 100, so x equals 10. All right, got that down. Now what about y? Y is my short leg. I don't have a short leg, but in this picture, it's my short leg, I should say. So then if we look back at our theorem, it's going to be 5, so this guy right here, and then times c, the whole thing. And so what is this whole thing? It's 25. So it's going to be 5 times 25, and it's the square root of that. And so y equals the square root of 125. Is there a perfect square that goes into 125? Yep. 25 and 5. So y equals 5 square roots of 5. And again, we used this down here. Since it was my short leg, I got to go back here and look to see. Okay, looking at my short leg is my x times my c, so my short leg of this triangle times the long guy right here. All right, so the next one is the long leg that we have to find, z, and so that's going to be my long leg of this triangle, and then c of that, the whole side. So z is going to be the square root of, okay, so it's my long leg, and so I'm going to take 20, my long leg here, times c. So 20 times 25. 20 times 25 is 500. So is there a perfect square that goes into 500? Yep. 105. So z is going to end up being 10 square roots of 5. So we're using those two theorems to help us out. Okay, let's go ahead and do this one. Okay, since we're short on time here, I went ahead and wrote out the work for you. And this is what you should get. Come with questions. If you have any questions, please ask. Write them down. I'm going to ask at the beginning of class if there were any questions. Okay, so z is going to equal square root of 200. So it is 102. So it's going to be 10 square roots of 2. X ends up being 296. and 4 goes into that. So we have 4 and 74 actually. So x equals 2 square roots of 74. Y ends up being 925. So 25 is going to go into it. And, oh, excuse me, I did that wrong. I was wondering, I was like, hey, that doesn't work out. So it should be 25 times 37. So 25 and 37. Let me get my color back here. So y is going to be 5 square roots of 37. Okay, write down your questions. Okay, I want to know your questions. I want to know specific questions. I don't just want you to say, hey, I don't get this. What don't you understand? How far can you get? And then what makes it confusing for you? Okay. All right, so I explained a lot in this, kind of tied in geometric mean here, using the geometric mean to find the missing sides. And yeah, that's all I have. Bye guys, have a great day. Play in the rain.